For the first time, space itself is breaking its own rules. Something is happening inside our solar system that shouldn't be possible. Telescopes across the world have locked onto an object that seems to have entered from deep interstellar space and then, inexplicably, begun to slow down. They're calling it 3I Atlas. But what has scientists losing sleep isn't its name. It's the fact that, for reasons no one can yet explain, this visitor from another star system isn't leaving. It's acting as if it intends to stay. When I first reviewed the early trajectory data, I remember staring at the screen and feeling a deep unease. The orbital pattern didn't make sense. Instead of accelerating past the sun, as every comet and rock does under solar gravity, 3I Atlas was decelerating, like a spacecraft easing into orbit. And the numbers weren't small. It was slowing by nearly 18 meters per second, a measurable, consistent drag that defied every known model of celestial dynamics. No comet does that. No asteroid behaves that way. Even with outgassing or dust jets, there's always an identifiable physical mechanism. This one? Nothing. Just silence and precision. Immediately, the astrophysics community erupted. Some compared it to Oumuamua, the mysterious cigar-shaped interstellar object that flashed through our skies in 2017 before vanishing forever into the dark. But Oumuamua accelerated as it left the sun. 3I Atlas is doing the opposite. And that single difference changes everything, because acceleration can be dismissed as radiation pressure or thermal recoil. But deceleration, that implies energy being used. Something is applying force against motion. Something is controlling its speed. NASA's Minor Planet Center confirmed the anomaly. Then came the first panic call, not from the public, but from inside the agencies themselves. The question wasn't what is it, but why is it stopping? In the sterile calm of mission control, you can feel the tension shift when the laws of physics start to look optional. For every scientist, that's both thrilling and terrifying, because it means our textbooks might be wrong. If you look at the orbit, 3I Atlas didn't enter randomly. It came in at an angle almost identical to the ecliptic, the plane in which all planets orbit the sun. That's a 1 in 10,000 probability for an interstellar object. It means this thing is moving with us, not against us. That alone made many astronomers whisper the word no one wants to say aloud: intentional. The panic spread quietly. Private emails, encrypted calls, and late-night data dumps began to circulate. Observatories in Chile, Hawaii, and Spain all confirmed the same readings. The deceleration wasn't an error, and it wasn't constant either. It pulsed, rhythmic, almost patterned, as though responding to solar proximity in real time. The sun would flare, and minutes later, 3I Atlas would adjust. It wasn't coincidence, it was synchronization. Of course, the official stance was cautious. NASA's public statement was deliberately plain. We are currently monitoring the trajectory and luminosity variance of 3I/Atlas, an interstellar object first observed in April. Further analysis is ongoing, but behind that measured tone, internal memos leaked describing it as the most significant non-terrestrial anomaly since 1977. That's the same year the wow signal, the strongest possible candidate for alien communication, was detected. For many of us in the field, that comparison wasn't random. It was a coded admission that something unprecedented might be unfolding again. What we're witnessing now could redefine everything we know about cosmic motion and perhaps about intelligence itself. If this object has truly slowed itself into a solar orbit, it means it's no longer a visitor, it's a resident. And that changes the balance of our solar system in ways we're not ready to confront. Because if something from another star system can enter our neighborhood, stop and stay, then our understanding of control, of propulsion, of cosmic agency is no longer human monopoly. I often say that the universe is a silent conversation between matter and energy. But 3I Atlas speaks a new dialect. It's rewriting the grammar of motion, the syntax of gravity. And as we listen closer, we might not like what we hear. When we first confirmed that 3I Atlas was slowing down, the reaction inside NASA was almost disbelief. Objects from interstellar space don't tap the brakes. They fall freely through gravity's hands, obeying equations that haven't changed since Newton. Yet this one resisted that pull, as if something inside it understood how to fight the sun itself. I've spent my career describing how space is ruled by predictable laws, but this object behaves as though those laws are only suggestions. To grasp why this is so disturbing, imagine a rock thrown across a frozen lake. It glides, frictionless, until it eventually stops. That's how every comet behaves. Pure momentum, no self-control. But now imagine that rock choosing to stop halfway, without touching anything. That's what 3I Atlas is doing on a cosmic scale. The deceleration curve isn't random. It's smooth, deliberate, consistent with an applied counterforce. If this were a natural phenomenon, it would require an impossible set of conditions. A constant jet of gas venting in perfect symmetry, no thermal drift, no fragmentation. Our instruments see none of that. It's as though the object is operating under a guidance system. Inside the Jet Propulsion Laboratory, analysts tried to model it using every known mechanism. Solar pressure, sublimation, magnetic drag, nothing fit. One physicist joked that maybe the object had learned how to surf the sun's magnetic field like a solar sail that knows where it's going. The laughter didn't last long. A few hours later, new readings showed microadjuvants, velocity changes of less than a millimeter per second occurring at regular intervals as if reacting to solar wind fluctuations. Those patterns looked eerily like course corrections. Now let's be clear, no one at NASA will publicly say it's artificial. That word alone could trigger panic, funding freezes, and congressional hearings. Instead, they use terms like non-gravitational influence or anomalous orbital deviation. But when you read the internal correspondence, it's hard to ignore the subtext. One senior engineer wrote, "If this continues, we'll have to classify it as a controlled trajectory." Controlled, meaning guided. That single word has kept entire departments awake at night. The implications are staggering. To slow an object of that mass against solar gravity would require an energy output comparable to a medium-sized fusion reactor. That's technology far beyond anything we possess. And yet it's happening right now, just a few 100 million kilometers from Earth. If it's natural, then we've discovered a completely new type of astrophysical process. If it's not, then someone or something has entered our solar system and chosen to stop. When the preliminary energy models reached me, I noticed something else. The object's deceleration rate wasn't constant. It followed a logarithmic curve, tapering as it neared a stable orbit between Mercury and Venus. That orbit is no accident. It's one of the most thermally stable regions in the inner solar system, a perfect parking space for observation. If I were designing a probe to study the sun and the planets, that's exactly where I'd place it. Around this time, communication between NASA, ESA, and the Japanese Space Agency went dark. Data that were once public suddenly became encrypted. The raw feed from several solar tracking satellites was temporarily suspended for calibration. Within the scientific community, that phrase is a red flag. It usually means they've seen something they don't want the public or rival agencies to analyze just yet. Still, fragments of information leak out. Amateur astronomers have reported a faint, recurring pulse of reflected light from 3I Atlas, repeating every 11 hours. Some think it's just tumbling rotation. Others suspect modulation, an intentional signal aligned with the solar wind cycle. If that's true, we're not just observing motion, we're witnessing communication. When I'm asked what keeps me up at night, it's moments like this. Because physics is supposed to give us certainty, a sense that the universe follows rules we can understand. But 3I Atlas is rewriting those rules one equation at a time. Every new measurement widens the gap between what we can explain and what we can only imagine. And as that gap grows, so does a silent question hovering over every lab and control room on Earth. What happens if it answers back? In the following days, every observatory on Earth that could turn a telescope toward the sun did so. From Hawaii to Chile, from the Canary Islands to the icy domes of Antarctica, we pointed our eyes at a single silent traveler, 3I Atlas. And almost immediately, the data began to show something that shouldn't exist in nature. Rhythm, not the chaotic flicker of tumbling metal or the random shimmer of sunlight on ice, but patterned intervals of reflection, repeating with mechanical precision. Each cycle lasted exactly 11 hours and 21 minutes. The signal dimmed, brightened, and dimmed again, as if the object was turning with deliberate timing. When I overlaid that data against the solar wind's periodic shifts, the synchronization was too precise to dismiss as coincidence. It was adapting to solar pressure, responding to fluctuations in radiation, like a sail adjusting to wind. That's not passive physics. That's control. Inside NASA's Deep Space Network control room, analysts grew tense. One junior astronomer described watching the light curve pulse in real time. "It's like it's breathing," she said. The phrase caught on. Within hours, scientists across continents began referring to the object not as a rock or a fragment, but as it. A subtle linguistic shift, but in science, pronouns matter. It's the difference between describing an object and suspecting intent. Then something even stranger happened. Over 3 consecutive observation cycles, 3I Atlas emitted a brief ultraviolet flare, barely detectable but consistent in shape and timing. Triangulation placed its origin not at random surface points, but along a single latitude line, as though the energy was being discharged through a controlled seam. The flare pattern matched no known cometary process. In fact, it matched nothing we'd seen before. At that point, the European Space Agency ran a deep field analysis using their solar orbiter. The readings confirmed microstructural regularity across the object's reflective surface, parallel striations only a few meters apart, evenly spaced like the ribs of a heat radiator. Naturally occurring ice or rock simply doesn't form that way. One engineer whispered the question everyone else avoided. Could it be built? The following week, a leak surfaced from an internal JPL memo describing non-random albedo variations in plain terms, reflections too organized to be natural. The memo was quietly retracted, but by then, the debate had spilled onto encrypted academic forums. Some theorists suggested that the striations could be part of an adaptive material, perhaps a metamaterial designed to regulate heat or capture energy. If that's true, we may be looking at a structure capable of surviving direct solar radiation, a feat even our most advanced spacecraft struggle to achieve. But the real shock came when orbital simulations predicted that 3I Atlas wasn't just hovering randomly, it was stabilizing into a nearly circular path around the Sun, just inside Mercury's orbit. That's a region no natural interstellar body should ever occupy for long. Gravitationally unstable, thermally extreme, it's a death zone for comets and asteroids. Yet this one remained steady, tracing its orbit with surgical precision. What unsettled NASA most wasn't the orbit itself, but the angle of inclination. It aligned almost perfectly with Earth's orbital plane, within 0.3 degrees. That's the same plane we use to launch interplanetary probes, the optimal trajectory for observing multiple planets without wasting energy. To choose that angle intentionally would require foresight, navigation, and knowledge of celestial mechanics far beyond chance. The longer we observed, the clearer it became that 3I Atlas wasn't behaving like a wanderer. It was arriving. Its movement, its rhythm, even its silence, all suggested purpose. The question now shifted from what is it to why here? Some scientists proposed that it could be a fragment of ancient alien technology, drifting dormant for eons until captured by the sun's gravity. Others speculated that it might be an automated probe, programmed to decelerate and study solar activity. But privately, a few of us began to wonder something more unsettling. What if it's been here before? What if interstellar visitors aren't accidents at all, but part of a recurring pattern that humanity has simply never noticed until now? That's when the whispers began. A rumor spread that one of NASA's solar monitoring satellites had briefly picked up an electromagnetic pulse, subtle but structured, emanating from the object's direction. The pulse resembled an encoded signal, repeating with prime number intervals. It was dismissed publicly as instrumentation error, but quietly, several agencies recalibrated their sensors and waited. They didn't have to wait long. Within 72 hours, the sun flickered. When the sun flickered, every alarm in NASA's Solar Dynamics Observatory went off at once. The brightness dropped by a fraction of a percent, small enough to dismiss as noise, but structured enough to demand attention. Because this time, the fluctuation repeated 4 times, each pulse perfectly spaced apart, each drop lasting 0.13 seconds. The sequence wasn't random, it was rhythm. And when nature speaks in rhythm, we listen, because physics doesn't stutter. In that moment, humanity's greatest scientific institutions went to war with themselves. On one side stood the skeptics, the defenders of natural law, insisting this was nothing more than magnetic turbulence in the sun's outer corona. On the other were those, like me, could not ignore the timing, the precision, the almost deliberate synchronization with 3I Atlas's position. The pulses aligned with the object's orbital phase within a tolerance of 0.01 seconds. That's not cosmic coincidence, that's choreography. I remember walking into the observatory that night, 3 a.m., silence except for the hum of processors, and seeing the light curve on screen. There it was, a faint but perfect square wave signature, not thermal, not acoustic, a modulated pattern. I've spent my life studying waves, electromagnetic, gravitational, quantum, and I know what random looks like. This wasn't random. It was engineered. Within 24 hours, every major astrophysics department on Earth had an opinion. Harvard released a cautious statement calling it a unique solar interactive phenomenon. The European Space Agency called for more data. But behind closed doors, the tone shifted. One internal communication from the ESA's astrophysics division, leaked later that week, read bluntly, "If Atlas is generating coherent light modulation synchronized with solar cycles, this represents non-natural intelligence." The media got wind of it within days. Headlines screamed across every screen, "Alien technology near the sun," and "NASA scrambles to explain flicker event." The public loved it, scientists hated it, because speculation spreads faster than proof, and proof takes time. But time was exactly what we didn't have, because the flicker kept happening. Every 72 hours, precisely aligned with 3I Atlas's periapsis points, each time slightly stronger. At Caltech, a young plasma physicist named Reena Chowdhury proposed something radical. What if the object wasn't emitting light, but reflecting it? The sun's radiation could be bouncing off an engineered surface with deliberate modulation, like a heliograph transmitting information through timed flashes. She calculated that even a small panel, angled precisely, could encode binary signals using reflected solar photons. And here's the part that shook us. Her model predicted the exact timing pattern we'd observed. If she's right, then 3I Atlas isn't just passively existing, it's communicating. Not broadcasting in radio, not transmitting through microwaves, but through light itself. Silent, elegant, untraceable unless you're watching the sun closely, which we only started doing with high enough precision in the last decade. That means, if this is a signal, it might have been happening for centuries. Naturally, the pushback came hard. Coincidence, they said, instrumentation error. But then something undeniable emerged, a fifth pulse. This one didn't just match Atlas's orbit, it occurred during an otherwise stable solar window. NASA's internal telemetry verified that no magnetic storms, no solar flares, no coronal mass ejections could account for it. The flicker was localized. It wasn't coming from the sun itself, it was being cast upon it. Imagine shining a laser pointer at a screen. Now imagine that screen is the sun. That's the scale of precision we're dealing with. From that moment on, I knew. Whether natural or artificial, something unprecedented was unfolding. A comet doesn't slow down deliberately. A natural rock doesn't flash in binary intervals. And the sun, the most stable beacon in our sky, doesn't pulse on command. The pieces didn't fit. But if 3i Atlas was indeed maneuvering, decelerating, reflecting, and now communicating, then we were witnessing the first real test of our readiness as a species. And I'll be honest, we weren't ready. Governments panicked quietly. Within days, space agencies began encrypting all real-time solar data streams. Civilian observatories found their access throttled, sometimes for maintenance, sometimes for calibration. But the truth was clear. Someone, somewhere, didn't want this story to spread. That's when the whispers started again. Reports of private satellites losing telemetry near the object. Amateur astronomers claiming to have recorded faint microwave spikes on the same frequency bands used by deep space communication arrays. Coincidence stacked upon coincidence, until the coincidences began to look like a pattern. And that's when something happened that forced the entire scientific world to stop pretending nothing was wrong. On October 17th at precisely 2:44 UTC, 3i Atlas turned. Not drifted, not spun, turned. At 2:44 UTC, the tracking data from the James Webb Space Telescope changed. The object's reflective axis, the bright vector we use to measure its orientation, began to shift, slowly at first, then decisively. 3i Atlas was no longer tumbling randomly through the solar wind. It was rotating with purpose until its specular reflection lined up perfectly with one specific target, Earth. When I saw the data, my first reaction wasn't excitement. It was silence. The kind that sinks into your bones when your mind recognizes a pattern your heart refuses to believe. Because that axis alignment wasn't statistically arbitrary. Out of every possible direction in three-dimensional space, this object had chosen to face us. And as it did, its velocity dropped again. Another 0.1 kilometers per second, a gentle, deliberate correction like a spacecraft adjusting its trajectory. Inside NASA's Jet Propulsion Laboratory, the situation escalated from observation to containment. Emergency channels went live. Lock external feeds. Verify Doppler analysis. Cross-check with Mars orbiters. Within an hour, the internal memo went out. Possible directed activity from 3i/Atlas. Classification temporary blackout. For the first time since Oumuamua, global astronomy went dark. Let me explain what that means. Normally, all space telemetry from international observatories is open access, a system built on transparency. But that morning, the data pipelines began freezing one by one. European Space Agency feeds redirected. Japan's National Astronomical Observatory displayed restricted bandwidth, and the private optical array in Chile, the only remaining public feed, suddenly went offline. For maintenance, the blackout was complete. Still, data leaks faster than bureaucracy can contain it. Within hours, independent astronomers noticed an anomaly in the intensity curve of the object's reflection. It wasn't steady anymore. It was pulsing, not in a random flicker, but in a binary cadence. Long, short, short, long, short, short. A repeating triad every 27 minutes. The pattern was identical across multiple observation points, even after accounting for atmospheric interference. When I saw that sequence, I couldn't help but think, like a physicist and a communicator, it looked like a call sign, a beacon. And yet no one could agree on its origin. Some argued it was a rotational modulation artifact, a natural byproduct of the object's shape. Others whispered that the intervals were too precise, too symmetrical, too mathematical, because nature doesn't produce Morse code. Meanwhile, inside NASA's Solar Dynamics division, fear replaced skepticism. Someone had leaked an internal message chain showing senior analysts discussing proactive observation risk. One line from a systems engineer read simply, "If this trajectory correction continues, projected line of sight intersects Earth orbit in 47 days." It wasn't a collision alert, not yet. The deceleration pattern suggested 3i Atlas wasn't falling toward us, but tracking us, following the planet's orbital position as if maintaining visual lock. That single detail changed everything. For the first time, NASA activated its Deep Space Contingency Framework, a classified protocol originally designed for unknown objects approaching from outside our heliosphere. That same night, I received a call from a colleague inside ESA's Jupiter division. She whispered, "They're not telling the public, but the object's light reflection shifted spectra. There's hydrogen ionization consistent with plasma discharge. Directed plasma, directed, not radiated." If that's true, then 3i Atlas wasn't just moving. It was using energy sufficient to alter its own position in gravitational space, something that, until now, only human spacecraft have been able to do intentionally. Across the world, every major observatory turned its focus toward the same target. Beijing's Purple Mountain Observatory, Chile's VLT array, the South African Large Telescope, all locked onto the same coordinates. Within 24 hours, the triangulated data revealed something even stranger. The light reflections weren't just aligning with Earth, they were following the rotation of our planet, as if tracking major observation sites. It was aware of where we were looking from. I stood in front of the data display that night, watching the digital overlay rotate. It was unmistakable. 3i Atlas wasn't behaving like a drifting rock or a lost relic. It was acting like a probe, observing, adjusting, responding. And then, just when we thought it couldn't escalate further, something happened that froze every scientist monitoring the feed. The pulses changed. The cadence became faster, long, short, then paused, and for 0.13 seconds, a single burst of reflected light flared brighter than the surface of Venus. When decoded through standard binary mapping, the pattern translated to one clear, haunting symbol. 0, 1, 0, 1, alternating endlessly, the universal language of computation. At that moment, I realized something that sent chills through me. For the first time in recorded history, an object from outside our solar system wasn't just being observed, it was observing us back. And then, without warning, all public feeds cut to black. For the first time in my career, I found myself staring at an empty data screen, realizing that silence, not noise, was the real signal. Because when every telescope on Earth suddenly stops reporting at the exact same moment, that isn't coincidence. That's coordination. Something or someone had decided that what came next should not reach the public. But as every scientist knows, information never truly disappears, and it leaks through the cracks. 48 hours after the blackout, fragments began emerging from encrypted channels inside NASA's Deep Space Network. At first, they looked like static interference, irregular waveforms embedded in background telemetry. But then one signal analyst noticed a recurring harmonic. The pattern wasn't random. It contained modulation signatures at precise frequency intervals, mathematical ratios of P and E constants that no natural process ever produces by accident. In simple terms, someone was encoding information into reflected sunlight. Let me emphasize the gravity of this discovery. The data didn't originate from any Earth-based broadcast. It came from the directional reflection of solar radiation bouncing off 3i Atlas. The pulse intensity varied with deliberate consistency, almost like an optical transmission. A beam of modulated light, coherent across millions of kilometers of space. To an astrophysicist, that means intent, purpose, a message. According to a leaked briefing from the European Space Agency, codenamed Project Helios, the light stream lasted exactly 7 minutes and 14 seconds. It contained repeating frequency bands that, when converted into amplitude spectrograms, produced a waveform eerily similar to a human heartbeat. And when decoded into binary, one phrase emerged with chilling clarity: stable orbit achieved. That line spread through the scientific community like wildfire. If genuine, it meant 3i Atlas had completed its maneuver, using the sun's gravity to slow itself down, stabilize its trajectory, and remain in our solar system indefinitely. Not a visitor anymore, a resident. NASA's official statement came 3 days later, downplaying the event as solar interference near perihelion. But behind the scenes, panic rippled through global security channels. The United Nations Office for Outer Space Affairs scheduled an emergency closed-door meeting. Military communication satellites began transmitting in encrypted intervals typically reserved for nuclear readiness drills. Something had shifted. Humanity had just witnessed an interstellar object stop moving, intentionally, and stay. And here's the part that keeps me awake at night. Once it stabilized, 3i Atlas didn't power down. Its albedo, or reflectivity, increased by 17%. That's impossible for an inert body unless its surface properties are actively changing. It's as if the object adjusted its panels, absorbing sunlight, harvesting energy, maybe even deploying something we can't see. Then came the atmospheric echoes. Radio astronomers in Puerto Rico, Australia, and Chile detected faint microwave bursts synchronized across global observatories. The bursts weren't random noise, they mirrored the same timing as the earlier light pulses. A global triangulation placed their origin not from deep space, but from near solar orbit, the same region where 3i Atlas had just parked itself. It was as though it had begun broadcasting not to us, but from us, using the sun itself as an amplifier, bouncing signals outward, beyond the heliosphere, a relay station. Now imagine the implications. If this object is transmitting, then we aren't its destination, we're its launch point. We've become the midpoint in a communication network spanning interstellar distances, which raises one haunting question: who or what is listening on the other end? Inside the Pentagon, the Advanced Aerospace Threat Division reportedly issued a Level 4 contingency review. No public acknowledgement, no press release, but leaked satellite directives show multiple classified surveillance payloads being V-tasked to solar orbit observation. One code name appears again and again: Project Horizon. Its purpose, according to an internal memo, is to determine whether 3i Atlas emissions represent data transfer, propulsion diagnostics, or directed information exchange. But then, just as quickly as it began, the signal vanished. On October 29th at 22:09 UTC, the precise moment 3i Atlas reached its perihelion, the transmission cut off completely. Every monitoring station recorded the same terminal silence, as though someone flipped a cosmic switch. And in that void, a new mystery began. 12 hours later, the Solar Dynamics Observatory captured faint anomalies along the sun's magnetic equator, streaks of plasma forming geometric loops that mirrored the object's previous pulse cadence. Long, short, long, short. For 2 hours, the sun itself appeared to flicker in binary. Then the pattern dissolved, leaving nothing but radiant quiet. Was this feedback from the transmission, a side effect of electromagnetic interaction? Or had the sun, our own star, momentarily become part of a network we don't yet understand? For now, all we can do is observe and wait, because as of tonight, 3i Atlas remains in stable solar orbit, motionless, silent, and perfectly aligned with Earth's ecliptic plane. It hasn't moved in over 72 hours. No more deceleration, no new signals, just stillness. But as any physicist will tell you, silence is not absence. It's potential energy waiting to release. And when it does, we may finally learn whether this object is a messenger, a machine, or something far more profound. Until then, remember this: for the first time in human history, something from another star system didn't just visit our neighborhood, it decided to stay. And maybe, just maybe, it's been waiting for us all along.